In this video, you'll learn how to build an AI agent from scratch in Python in just a few minutes. I'll walk you through everything step by step. This will be very beginner friendly, and you'll learn how to make something quite interesting in Python with some popular frameworks like LangChain. I'll show you how to use various LLMs like Claude or GPT, how you can give the agent access to various tools, and how you can structure the output of the agent so you could use it in your code. So let me show you a quick demo of the finished project, and then we'll go through exactly how to build that. So you can see that I've built what's known as a research assistant. You can make this anything that you want. This is just a quick demo for the tutorial, and it asks me what it wants to research. So I'm going to paste here, tell me about LangChain and its applications, and I'm going to tell it to save it to a file so it can use the tool that I created to save the contents to a text file. Now this has access to some tools like Wikipedia and Google search. So you can see here it says that it's actually searching on Wikipedia with this query, gives us some kind of output here. And then if we scroll through, we can kind of see the entire thought process, and we can disable that as well if we want. Anyways, you see that we get some output here. We have a topic, we have a summary, we have the sources that it used, and then the various tools that it used as well. And if we go here to the left-hand side, you can see that it actually generated a text file for me that contains the research output as well as a timestamp and all of the content that it gave us. Of course, we can make this much more advanced. We can give it access to many more tools, and we can get it to do some really cool things with that tool access, but this will really get us started and show you how you can write these types of agents. So I hope you're excited. Let's go ahead and get into the video. So let's begin with a few prerequisites in order to follow along with this video. First of all, you will need Python installed on your system, and ideally Python version 3.10 or above, but the version won't be too important. You'll also need some kind of code editor. In this case, I'll recommend using something like Visual Studio Code, which is what I currently have open on my computer. You'll then need to open a new folder, so you can go to File, if you're in VS Code for example, Open Folder, and you can just make a new folder. In this case, I made one on my desktop by clicking New Folder, gave it a name, and then I opened it. That folder is called AI Agent Tutorial, so I just opened it here, and you can see this is where I'll be working. From here, we're then going to need to install some different Python dependencies and get access to some API keys. So let's start with the Python dependencies. What I'm going to do is make a new file. I'm doing that by pressing this button up here that says New File, and I'm going to call this requirements.txt. I suggest that you do the same here, but there's other ways that you can follow along with this. Now inside of this file, I'm going to paste the following 7 lines of code. You can manually write these out, or you can copy this code from the link in the description. There'll be a GitHub link that has all of the code for this video, and you can find this file in there. Now these are the packages that we'll need in our Python environment in order to work with this agent. So what we're going to do now is we're going to create something known as a virtual environment. A virtual environment is an isolated place where we can install these dependencies, and then we can work in this environment for the project. If you're not familiar with virtual environments, or you don't want to set one up, then you can simply run the command pip install -r requirements.txt from your terminal, ideally in VS Code, in the same directory where your file exists. So in this case, we're inside of the AI agent tutorial, and then I'm running this command pip install -r and then pointing it to requirements.txt, which is again in this same directory, which is why this will work. Otherwise, you can do pip3 install -r requirements.txt, and that will install the dependencies globally. However, I'm going to suggest you create a virtual environment, and to do that, you're going to type a different command, which is going to be Python -m venv and then venv. This is going to use venv to make a new virtual environment called venv in the current directory. If you're on Mac or Linux, you can adjust this to Python 3. On Windows, it should simply be Python. When you run this command, you should see that it takes a second, and then you get a new directory here called venv. Now what we need to do is activate the virtual environment, and then we can start using it, and everything will be the same as it normally would. So in order to activate the virtual environment, if you're on Mac or Linux, you're going to type source / the name of the virtual environment, which is venv, and then this is going to be /bin/activate. Okay, let me just type this correctly for you guys, and then you can hit enter. This is if you're on Mac or Linux. If you're on Windows, the command is different, and it's simply /venv/scripts/activate. Okay, this is Windows. The other one is Mac or Linux. You hit enter, and then you should see that you get this venv as a prefix in your terminal. Now we can install the dependencies like I said before. So pip install -r requirements.txt or pip3 install, and this should install all of the dependencies into this virtual environment, and we'll be good to start working. So the dependencies have now been installed in this virtual environment, and I just want to make you aware that if you see that I have like this autocomplete popping up in my editor and you're wondering what that's from, that's actually from GitHub Copilot. So if you want to use that, you can do that for free by going to extensions and then typing GitHub, and you can see Copilot, so pop up right here. I've just installed this in my editor, so that's why you're seeing the autocomplete. And speaking of Microsoft's GitHub Copilot, yeah, you know, that insane AI tool that replaces 95% of your manual typing, well, that's just one example of how generative AI coding tools are transforming how us developers tackle software engineering. Now, personally, my workflow has changed massively over the past 2 years, and to be honest with you, I'd say it's for the better. Whether it's generating unit tests, stubbing classes, or even writing entire features, I'm sure that you guys have come up with some pretty creative ways to use these AI tools. Now, that's actually something that Microsoft is interested in, empowering developers to learn new skills and showcase the creative and useful ways that they've used GitHub Copilot to solve everyday problems. Now, Microsoft is currently running #CodingWithCopilot, where they're highlighting and celebrating the standout ways that developers have used GitHub Copilot to make their jobs easier. Now, you can share your own GitHub Copilot story for a chance to be featured on the Microsoft developer social channels. If you have a cool story on how you have used GitHub Copilot, then you can share it anywhere, including platforms like Instagram, X, YouTube, or LinkedIn with the hashtag #CodingWithCopilot. I'll personally be reviewing all of the submissions for a shout out in a future video, so make sure to tag me. I'd love to check them out. Now, we all know that AI is reshaping the industry, and devs are able to leverage this tool to tackle and solve problems more easily and creatively than ever before. Now, a massive shout out to GitHub Copilot and Microsoft for sponsoring today's video, and I look forward to reviewing some of your submissions in a future video, so stay tuned. Okay, so now that everything's set up, it's time to start writing some code. So what we're going to do is make a new file in this folder called main.py. This will be the file where we're going to write most of our code. We're also going to make another file called tools.py. We're just going to separate things out so that we put the tools in this file and the main logic here so that things are a little bit easier to read and more organized. We're also going to make one more file called dot and then env. This is an environment variable file where we're going to store some credentials for things like our GPT API key or our Anthropic API key, because I'm going to show you two ways to use, well, two different LLMs within this agent. Okay. So we're going to go to main.py and we're going to start by setting up a very simple agent. We're going to run the agent and then we'll start adding all of the tooling functionality. So to begin, we're going to start importing some things that we need. So we're first going to say from .env, import load.env. We're then going to say from Pydantic, import, if we can spell this correctly, the base model. We're then going to say from LangChain, and this is going to be underscore OpenAI, import, and this is going to be chat OpenAI. And then additionally, and this is optional, I'm going to say from LangChain Anthropic, import, and this is going to be chat Anthropic, because I'm going to show you how you can choose between either OpenAI or Claude or GPT or Claude for this video. Beneath that, I am going to type this line, which says load.env. What this is going to do is load the environment variable file that we created here, which we'll fill in just a minute, so that we have all of the credentials that we need to continue with the tutorial. Next, what we want to do is we want to set up an LLM. So our agent will begin with some type of LLM. We can just use the LLM normally, but what we're going to do is give it to an agent and then give the agent some tools and some various other functionality, like being able to generate output in a specific format. So we're going to start by saying LLM is equal to, and here's where you're going to have a choice. You can choose to use chat OpenAI, which means you're going to be using something like an OpenAI API key, or you can use something like chat Anthropic. So you can see here, it's giving me the autocomplete for chat Anthropic. Now for both of these, what you need to do is specify the model that you want to use. So if you're using something like OpenAI, then you can say model is equal to, and then again, something like GPT-5 Turbo, or you could use GPT-4 Mini or 4o Mini. There's all kinds of different models. You can just go with something like GPT-4. I believe also 4o Mini is another option as well. And as for the API key, don't worry, I'll show you how you load that in 1 second. Now, if you're using Anthropic, then you want to load in probably the Claude model. So I'm just going to paste in the one that I'm using here. So Claude 3-5 Sonnet, and then this is the version that I picked, but you can pick a different version. And when this video is out, there may be a more recent version that you can select here. Either way, you're going to select a model and you're going to choose what type of LLM you're using. In my case, I'm using chat Anthropic because I'm currently rate limited by OpenAI. Okay, so now we've selected the LLM. However, we need to provide an API key in order to be able to use this LLM. So regardless of if you're using OpenAI or Anthropic or really any other provider, you're going to need to go into your environment variable file, this .env file, and you're going to need to write one of the following variables. The first is if you're using OpenAI. You're going to have to say OpenAI underscore API underscore key is equal to, and then you're going to have to paste the API key here. Lastly, if you're using Anthropic, then how do you spell Anthropic? Let me make sure I do this correctly. You're gonna have to do Anthropic, if we can type this correctly, underscore API underscore key is equal to an empty string. So again, if you're using OpenAI, use this. If you're using Anthropic or Claude, you're gonna use this. I'm gonna show you how to get both of the API keys, so hang tight for 1 second. Okay, so in order to get the API keys, I believe you do need to have credit card information on file. Don't worry, this will cost you like 1 cent at most. If anything, it should probably just be free. Regardless, you can go to platform.openai.com/API keys. I will leave this link in the description and simply press generate new key, give it a name, create the secret key, and copy it if you're working with OpenAI. And for Anthropic or Claude, you can go to this page right here, console.anthropic.com/settings/keys. Again, link in the description. Press create key, same thing, give it a name, and then copy that key. Obviously, do not share this with anyone. So now what I'm going to do is I'm going to close that and I'm going to paste in my key, and then I'm going to close this file so that I don't leak the API key to you. So my API key is now loaded. In order to test if this is working, we can invoke the LLM and run it locally from our computer. So in order to do that, we can say response is equal to LLM.invoke. And then I believe we can simply just pass a query. So something like, what is the meaning of life? Great. I love that that's giving me the autocomplete from the AI, and we can print the response. It's possible that we need to pass something else, but I think this is totally fine for right now. So now that we have that, we can simply run our Python code. Make sure that when you run the Python code, you're running it from within your virtual environment. And the easiest way to do that is, again, just to open up the terminal you created in VS Code, and then type Python and then the name of your file, which in this case is main.py, or Python3 main.py, and then hit enter. And you should see that we get a response. It might just take 1 second. So let's see. And we get some content and kind of some other metadata information from this LLM. You can see it says that's one of humanity's oldest, most profound questions, blah, 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 and we get the response. Okay, so that's how you use the LLM very simply. Like, we're just using the LLM. We haven't added any agent functionality. But next, what I want to do is obviously add some more content and make this a little bit more advanced. So after we have our LLM, the next thing I'm going to set up is something known as a prompt template. This is something that will kind of act as a template for any of the queries that we give to the LLM so that we can give it more information on what we actually want it to do. So for our prompt template, we're going to do the following. We're going to say from LangChain, and then this is going to be underscore and core. And then this is going to be dot prompts. And we're going to import the chat prompt template. Okay. While we're here, we're also going to say from LangChain core, and then this is going to be dot output underscore parsers. We're going to import the Pydantic output parser. Now, basically what we're going to do is we're going to define a simple Python class, which will specify the type of content that we want our LLM to generate. We're then going to give the LLM a prompt, and we're going to tell it, hey, answer the user's question, and as a part of your response, generate it using this schema or using this model. So it will give us output in a format that we can then know and kind of use predictably. You'll see what I mean in 1 second, but just bear with me while I write some of this code. So I'm going to create a class here, and this is going to be my response, or my research, response, okay? And this is going to inherit from my base model. Now you can make this class anything that you want. I'm just giving you a simple example here with like a response that we're expecting from the LLM. So the response that I want is I want it to generate for me a topic, and I want that topic to be of type string. So I'm going to specify that right here. I then want to have a summary, and I want that summary to be of type string. So I specify the type, right? Then I want to have some sources, and I want these sources to be a list of strings. So I'm going to type list, and then in square brackets, string. Then I'm going to have some tools used, and I'm going to type list and string. Now here is where you can just specify all of the fields that you want as output from your LLM call. You can make this as complicated as you want. You can have nested objects so long as all of your classes inherit from the base model from Pydantic. Okay, so you just need to make sure you inherit from base model, and then you can specify all of the fields that you want to have in your response model, and we can eventually pass that to the LLM. Now that we have this, what we're going to do is we're going to create a parser. So we're going to say parser is equal to the Pydantic output parser, and we're simply going to pass the research response, but we're going to do this as the Pydantic object. Okay, so we're going to say Pydantic object is equal to this. There's other ways that you can set up this parser, like using JSON, for example, or using other types of kind of, what do you call it, schemas, I guess. But in this case, we're using Pydantic, which is very popular within Python. So this parser will now allow us to essentially take the output of the LLM and parse it into this model, and then we can use it like a normal Python object inside of our code. Okay, so next we need to set up a prompt. Now I'm just going to copy this in because I don't want to spend a ton of time writing it, and I'll walk through it line by line. So we're going to say our prompt is equal to our chat prompt template dot from messages. Okay, then inside of here, the first thing we're going to specify is a system message. The system message is information to the LLM so it knows what it's supposed to be doing. So we tell it you are a research assistant that will help generate a research paper, answer the user query, and use the necessary tools. And then the important part is that I tell it to wrap the output in this format and provide no other text, and I provide the format instructions. Okay, that's very important. Make sure you have this part. Lastly, there's a few things that you do need to add here. So you need to add the chat history, the query, this is coming from the user, and the placeholder, which is the agent scratchpad. Don't worry too much about these three fields right here. The only important one is the query. This is just necessary for the type of agent that we're going to create, and you can find all this information from the LangChain documentation. Okay, then we say dot partial. And what this means is we're partially going to fill in this prompt by passing the format instructions. So what this now does is it uses our parser that we created here, and it just takes this Pydantic model and turns it into a string that we can then give to the prompt. So we're pretty much just taking this model that we want to have our output in, converting it to a string, giving it to the LLM as part of the system prompt. So now it knows when it generates a response, it's got to do it in this format. So notice that format instructions here matches up with format instructions here. They're the same variable. That's important. You could call this anything that you want so long as you adjust both of the values here. Okay, and then these other values will be automatically filled in for us when we start actually running our agent. Okay, so now we have our prompt, we have our parser, we have our LLM, and it's time to create a simple agent. So we're going to say agent is equal to, and then we're going to bring in a function called create tool calling agent. So from the top of our code, we're going to say from LangChain, and then this is going to be dot agent import, and then create underscore. And notice there's all types of agents that you can create, but we want to, create tool calling agent. Okay. Now this is the one we'll use again. There's a bunch of ones that you can use here. So I'm going to use this function, and inside of this function, what we need to pass is the following. Our LLM, which will simply be equal to the LLM that we've already defined up here. And then we can pass it our prompt. So we can say prompt is equal to prompt. And then lastly, we're going to say tools. And for right now, we're just going to make this equal to an empty list. We'll specify some tools in a second, but for now, I just want to test the agent and make sure that the agent will work. Okay, so we have our agent, create tool calling agent, LLM, prompt, tools. And now we want to test the agent. So in order to test the agent, we need to import one more thing. So from LangChain.agents, we're going to import what's called the agent executor. The agent executor is just a way to actually execute the agent, right? So that's why we need to bring that in. And then down here, we're going to say that the agent underscore executor is equal to an agent executor. For the agent executor, we're going to say the agent is equal to our agent. The tools is equal to, again, just an empty list for right now. And we're going to say verbose, if we specify this, is equal to true so that we can see the thought process of the agent. If you don't care about the thought process and you don't want to see that, then you can just mark this as false or not included. So now we have an agent executor, and we can use the agent executor to generate some kind of response. So we can say our raw underscore response is equal to the agent executor dot invoke. And then when we invoke this, we need to pass in this prompt variable, which is query. Now you can have multiple prompt variables, and notice that they're all specified inside of braces. So we had the format instruction prompt variable that we filled in here. The chat history and the agent scratchpad will automatically be filled in by our agent executor, and then we're left with one more prompt variable, which is the query. And if you wanted to add multiple variables here, you could just do another one and you can say, name or something. And then here, when you invoke this, you're going to pass two things. So you'd pass the query, which is, what is the capital of France or something, and then the name of Alice. So you can pass multiple prompt variables. Again, in this case, we just need query, but I just wanted to show you that you can pass more if you want to. Okay. So we're going to invoke the agent executor. We're going to get a raw response. And for now, we can just print out the raw response. And I believe that that should be it. And this code should be working. So let me zoom out a little bit. You can see our imports. Again, you can find all of this code from the link in the description. Generate the LLM, make the parser, create our prompt with the prompt template. Then we have our agent and we create the agent executor and generate the raw response. So let's try this out and see if we get something. Give this a second. You can see it's going into the agent executor chain and it should generate a response for me. And you can see that we get that. What is the capital of France? And then it gives us kind of output, text, topic, and it gives us the output in this format. Now, if we just want to see the response that we're looking for, so like this kind of model, what we need to do is use the parser to parse this content. So what we're going to do is we're going to say our structured response is equal to parser.parse. And then rather than just parsing the raw response, we're going to say raw response.get. We're going to get the output key because it gives us kind of like a dictionary with multiple values. Like if you look here, I know it's a little bit messed up. You can see we have output and then we have an array and then we have another thing inside of here. So we just need to go inside of that. So we're going to say output at index 0 and then text. What this is going to do is it's going to get the output. It's going to get the text from like the first value of output, which is all we're going to have. And it's going to parse that with our parser into a Python object. So then if I go here and I print the structured response, let's run this again and I'll show you what we get. And don't worry, I'll slow down and go through all of the code again. Okay, so we're entering the agent executor chain. And you can see that we get this, right? So query, output, our text. And then when we print out the Python object, it gives us all of the fields that are in our Pydantic model. So we have the topic. If we keep going through here, we should get like a summary. Yeah, summary is right here. We have the tools used, and then we have the, if we keep going here, the sources, right? And it tells us where these sources came from. Cool. Okay, so that is that. And that allows us now to get it in the correct output. And the interesting thing, right, is that now that this is in the Python model, what I can do is something like structured response dot and then topic. And I can just access this topic, which is typed as a string, and I can just use that. So this is the really kind of neat part about using these structured output models, is that now I can get specific components from the response and actually use them predictably in my code rather than just having this plain text, which is usually what the models give you. So we've already got that part. We have our structured response. And just one thing we want to do is we just want to add a simple try catch here, or try except block, because it's possible the model can mess up and then this will give us an error. So if it doesn't give us the correct response type, which is possible, we can get an error. So what we're going to do is just say accept exception as E, and we're going to say print, and we're just going to go, what do you call it here? Error parsing response. Then we're going to print out E, and then we're going to say the raw response like this. And we'll actually just do another one and we'll say raw response like that. Okay, you can make this look better if you want, but I'm just doing a simple error message so we can see kind of what's going wrong. Okay, so there we go. We have our try except, and now we need to do the cool part, which is adding tools. So of course, this is interesting, but we want to have the ability to call various tools. Tools are things that the LLM can use or the agent can use that we can either write ourselves or that we can bring in from things like the LangChain community hub. So what I'm going to do is go to my tools.py file, and I'm going to show you how to add 3 different tools. One for looking up Wikipedia, one for going to DuckDuckGo and searching something. These are all free. You don't need any API keys. And then one custom tool that we write ourselves, which can be any Python function. So we're going to go to the top of our code, and we're going to say from LangChain, and this is going to be _community, import, and then the Wikipedia, this is going to be .tools. And then we're going to import the Wikipedia query run. Then we're going to say from LangChain community.tools, and actually this is going to be .utilities. Getting carried away with the Copilot autocomplete here. We're going to say import the Wikipedia API wrapper. We're then going to say from LangChain, and actually can do this in one import up here, we're going to bring in the DuckDuckGo search run. Okay, so a tool that we can use. And then we're going to have two last imports. We're going to say from LangChain.tools, and we're going to import the tool. This will allow us to kind of wrap or create our own custom tool. And then we're going to say from datetime import datetime. Okay. Sorry, I know that was me messing around. I'm trying to remember what these imports actually are. So you can see we have some stuff related to Wikipedia, the DuckDuckGo search run. Again, all of these are free, but you will get rate limited if you use them too much. And then we'll be able to create our own custom tool. So let's start by simply creating the tool that can access DuckDuckGo, or kind of like search. Google search is what I'm calling it, even though it's DuckDuckGo search. So to do that, I'm simply going to say search is equal to DuckDuckGo search run. I'm just going to call that. I'm then going to say my search underscore tool is equal to a tool. For my tool, I need to give this a name. So I'm just going to say that this tool is called search. Okay. So we can say name is equal to this. The function is going to be equal to search.run. So this provides a function called run. So that's what we're passing here. And then what do we want to have here? We need to have a description for the tool. And this is just going to be search the web for information. Okay. So this is our tool. That's literally all you need to do. We've now created a tool that we can pass to our agent. The key thing is that you need to have some name. This namespace cannot have any spaces. So just make sure if you want to have something like, search web, you do it with an underscore, or you do it like with camel case. And then you just need to have a description so that the agent knows when it should be using this tool. This is a basic description, but you could give a more detailed description if you wanted it to only use the tool in a specific scenario. Okay, so that's our first tool. Now, in order to use that, we're going to go back into our main.py file and we're going to import it. So we're going to say from tools, import, and we're just going to import the search tool. Okay. We are then going to go to our agent, and before here, we're going to make a list called tools, and this is going to be equal to our search tool inside of a list. We're then going to pass our tools now to our agent as well as to our agent executor. Okay, so now it will have access to this list of tools. Right now we just have one tool, the search tool, but if we gave it access to multiple tools, then it can pick and use all of them or just the ones that are relevant. Last thing here, rather than just having the query be manually typed in, I'm going to just get it from the user. So I'm going to say query is equal to input, what can I help you research, ? And then we're just going to pass query here. So now the user will just type in the query themselves. Okay, and rather than printing the raw response, I'm going to print the structured output. Okay, so that we can use that as we see fit. All right, so let's come up here. Let's clear the screen and let's run and let's see what we get. And there was an issue here, could not import DuckDuckGo search package. Okay, so we just need to install DuckDuckGo search. My bad, guys. So I'm going to go to requirements.txt. I'm going to put this inside of my requirements so that I don't forget and that you guys will have it when you look at the code in the video. And I'm just going to run the command pip install and then DuckDuckGo search so that we're able to use that. Okay, so give that a second to run. All good. And now we can run the code again and hopefully this will work. What can I help you research? I want to know about sharks. Okay, and let's see what it gives us. Okay, so you can see that it's invoking search, so it's using this tool, shark biology, habit behavior research. Okay, that's an interesting search string. And you can see that it gives us back this research paper. And obviously, if we improve the prompt, we'd get a better response. But this is what we're looking for. Perfect. So that is the search tool. Next, I will show you how to set up the Wikipedia tool and then our own custom tool. So the Wikipedia tool is pretty straightforward. What we can do is below here, we can say our API wrapper is equal to the Wikipedia API wrapper. Inside of here, we can pass a few pieces of content or a few parameters. So we can say top K results. And in this case, just make it equal to 1. But if we wanted to return, say, 5 different types of results from Wikipedia, we could go with 5, right? We can change this to be whatever we want. Then we can say the doc content characters max. I'll just make this equal to 100 because this is a quick demo. But if you wanted to get a lot more content from the Wikipedia page, then you would put 1,000 or 10,000. Again, it will take longer to run and you may get rate limited faster because you don't even need an API key for this. But again, just showing you a quick example. So these are 2 parameters and I believe there's a few more that you can pass here, like the language, load all available metadata, etc. Okay, now that we have the API wrapper, we need to convert this to a tool. So we're going to say the wiki tool is equal to the Wikipedia query run. And then all we're going to do is just pass our API wrapper equal to our API wrapper. Now that's actually all we need for the tool. We don't need to wrap it in a custom tool. We can just pass this as a tool directly to LangChain. So what I'm going to do now is import the wiki tool. So say wiki underscore tool. And then I'm going to go here to my tools list, bring in the wiki tool. And now we can run this and let's see what we get. And if it's able to use Wikipedia. So I'm going to say same thing, sharks, or let's go hammerhead sharks. Okay, and let's see what we get. So you can see it's using Wikipedia, looking up the hammerhead shark, and then it's using search. Search hammerhead shark research latest findings. Okay, and then it gives us the response and it tells us that it used these two tools. Sweet. Okay, last thing, I'm going to show you how we make our own custom tool so we can save this to a file. So in order to save this to a file, we can actually just write our own Python function. So actually, let's go up to the top here. And this function, or any function for that matter, can be wrapped as a tool. So we're just going to make a function called save. And actually, I'm going to save some time because I don't think you guys need to watch me write this out. I'm just going to copy it in, called save to txt. We'll take in some data and we'll take in a file name. Now it's important that you give the parameters a type here so that the model knows how to call this function. So make sure that you type them. In this case, I've typed it as a string. If it was a more advanced type, you'd want to include that as well. So what I'm doing is I'm just writing at the top of the paper, research output, the timestamp, and then I'm going to write the data. And that data is going to be that Pydantic model, which you'll see in just 1 second. Okay, so that's my function. Now, once we have the function, we just need to wrap it as a tool. So to do that, we can say save underscore tool is equal to tool. And then we just do the exact same thing that we had here. So I'm just going to copy this, paste it. I'm going to change the function to be save to txt. Notice I didn't call the function. I just wrote the name of it. And then for the name, we're just going to say save text to file. Again, make sure we don't have any spaces. And then I will just kind of bring in this description, save structured research data to a text file. So it knows what this is doing. That's as easy as it is to make your own custom tool. So if you want a tool that calls an API, for example, you can do that. Just write a Python function, wrap it as a tool, and you can pass as many of these to your agent that you want and really get some advanced functionality here. So now we're going to bring in the tool. So same thing, we're going to bring in the save to txt. That's what I called it, right? No, sorry, save tool. Okay. And then we're going to put that in the list, save tool, and then we can start using the save tool. Now, the only thing is we just need to instruct the model to save this to a file. So I'm going to go python main.py. I'm going to say, let's research, I don't know, what do we want to research? Southeast Asia population or something, and say save to a file. Okay, and then it should use kind of all of the tools and save this to a file. And let's see if it does that and just give this a second to run. So you can see it just used Wikipedia. It's using what else? Southeast Asia. Okay, I think it's just my terminal is cutting off a little bit here. And it used the save text to file and then finished the chain, gave us the output. And now you can see we have our research output txt file. And inside of here, we get our timestamp, we get our topic, and we get all of this information. You can see the region has relatively young population, blah, 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 and goes through kind of all of the details. So there you go. We have just completed the project and built an agent from scratch in Python that has access to various tools. This is super cool. We are really just scratching the surface with what is possible here. I just wanted to give you a video that kind of overviewed the main components, the main topics that make up like 80% of the agent applications. And this really does get you quite far and allows you to build some really cool stuff. So I will leave the code link here in the description in case you want to check out the GitHub, which will have all of this content. You can just copy it and do whatever you want with it. If you enjoyed the video, make sure to leave a like, subscribe to the channel, and I will see you in the next one.